Okay, so good evening to all of you and welcome to this final event of the third series, Voices from Contemporary Philosophy. So as you all know at this point, this is a program which is promoted by our curriculum in philosophy, and it is organized and coordinated by Michele Nicoletti, Alessandro Palazzo, and myself. And it is a real pleasure for us to conclude this cycle with Professor Max Kistler. So I just want to thank him for being here, for having accepted the invitation to join us and to reach us from Paris, which is anyway some way to do. And it will be Professor Federico Laudisa from our university to introduce our guest speaker. And after that, we also have a discussant who is down there, I think. So Samuele Fasol from the University of Rome. So thanks to both of you for having accepted to contribute to the discussion. And now, Federico, maybe you can just introduce our guest. And thank you again so much.
First of all, my gratitude to Max Kistler and the organizers, my colleagues, for this really interesting cycle with this nice format. For those who were not attending this morning, the interesting and stimulating masterclass, I will say a few words of presentation of our guest speaker. Then I will leave the stage to him, and then Samuele Fasol will give some comments in order to activate the discussion, debate, and then we can open it also to the audience, of course. Max Kistler is a professor at the Unité de Formation et de Recherche de Philosophie at the University of Paris 1, Panthéon-Sorbonne. Since 2018, he is responsible of the pathway in logic and philosophy of science for the master in philosophy. He is also a member of the Institut d'Histoire de Philosophie des Sciences et des Techniques, of which he was director between 2016 and 2018. Max Kistler has a very strong background in philosophy of science and history of science. He obtained a PhD at the École des Hautes Études en Sciences Sociales with a thesis on the issues of causality and laws of nature, and also received the habilitation à diriger des recherches with the work on the role of mind in a world governed by causality. He also holds a master's degree in physics from the Ludwig Maximilian University of Munich. And this morning we had a very nice discussion on how the scientific background helped to shape his further career in philosophy. That was very interesting. And also a postgraduate degree in philosophy of linguistics from the University of Geneva. He has been president of the Société de Philosophie Analytique and president of the Society for the Metaphysics of Science. I will mention few among his several publications. First, the books, Causalité et loi de la nature for Vrain in 1999, with an English translation in 2006 for Routledge. La philosophie des sciences au XXe siècle, in collaboration with Anouk Barberousse and Pascal Ludwig for Flammarion. L'esprit matériel, réduction et émergence for ITA in 2016, a book which had a second edition in French in 2023, and then an English edition, The Material Mind, published this year for the University of Calgary Press. And then last, Metaphysics of Causation for Cambridge University Press. And of course, he published many papers, both in collective books for publishers such as Routledge, Springer, and Oxford University Press, and journals like Erkenntnis, Dialectica, International Studies in Philosophy of Science, Analysis, Synthèse, Philosophie, Revue de Métaphysique et de Morale, and other prestigious journals. His main research topics are in the fields of the philosophy of science, analytic metaphysics, and the connection between issues in both areas, philosophy of mind and cognitive science, and philosophy of physics. He will talk about natural grounding. So once again, thank you for being here, and I leave you the stage. Thanks.
Thank you so much for being here. Thank you for the organizers to have invited me. Thank you, Federico, for the presentation. I share the slides. So my task is to explain to you what I mean by natural grounding. And I suppose that many of you haven't ever heard of this quite recent term, grounding. And I start with a question that is in one sense very simple. Why are there composite objects and not only simple objects? And once you have an answer to this first question, you can ask for why these complex objects, given that they exist, have the properties they do. And this is typically one of those questions, if you are not a philosopher and you try to explain to your grandmother or to your cousins what you're thinking about, they will find it very strange that this is something that it's worth thinking about. But I trust that I will convince you that it's something worth thinking about. Why, if we accept the idea that there are fundamental particles, like what we learn in particle physics, we learn about fundamental constituents of reality, like atoms or protons and neutrons and electrons, photons, all these particles. And we learn that everything is constituted, everything is composed by these kind of physical particles. Everything in the universe, including us and living beings, tables and chairs, everything is constituted by these. And so why wouldn't reality just be fundamental particles, full stop? Why do sometimes some of these fundamental, for some of them, they stay by themselves in space and don't merge with anything, but some of them, sometimes they merge to constitute complex objects like tables and animals and humans. So why is that? It's a typical metaphysical question. Well, it's a metaphysical question, but my talk is about the question whether the answer to this question is mostly scientific, whether you can get an answer from science and be happy with that scientific answer, or whether you also need help from metaphysicians. So that's the question. And the strategy to ask such very general questions, it's like, why is there movement and why doesn't stand anything still? Why is there time? As you see, this kind of typically philosophical questions. How do you possibly tackle those general questions? The strategy that is seems to be fruitful, and I think that is a good strategy in this case as well, is to look for the simplest of all composite objects. So it is very tough to understand why there are humans with a mind and thoughts, given that they're composed by very simple constituents like atoms and molecules. This is very hard. So to tackle this very general question, the best strategy is to look at the simplest possible composite objects. So there are molecules which are very complicated, like DNA, many atoms. That is very hard to understand. So let's look at the simplest of all composite objects. And maybe hydrogen molecules are the simplest or among the simplest objects. So why would these molecules exist? And not only the atoms that make them up. So you have these two atoms and they compose a molecule. Why do they stick together? And so I tell you that I think that this question, even if it's a metaphysical question, in a sense, it has a scientific answer. It has 100% scientific answer. At least that's my thesis. And you can learn in physics, and I have learned when I studied physics in the quantum mechanics class, you learn an explanation for hydrogen molecules. And I'll tell you a little bit more why, how that works. I will not talk about physics in any detail. It's just a scientific explanation that has to do with the interaction between these two atoms. And that provides an explanation why they would stick together. Okay, so then the whole talk is about my puzzlement when I read metaphysicians, and here I quote Jonathan Schaffer in his paper, The Ground Between the Gaps, who says that to answer that kind of question, you need metaphysics. You cannot explain why there are molecules, given you have atoms, only by science. You also need metaphysics. What he says is substantive metaphysical principles are needed in all concrete transitions from more to less fundamental. So Mariological, I get back to this a little bit afterwards. Mariology is a priori axiomatic science, like theory, like it's like logic or mathematics with axioms. And one of the axioms of Mariology says that given any two objects whatsoever, there is a Mariological sum. It's just an axiom. Okay, so the question I'm asking is very different. It has nothing to do with Mariology in this sense. It's about real objects like tables and humans and objects that exist in space and time. And for these objects, there is not always fusion. If you have two objects, there is not also, in addition, an object that is the fusion of these two. No, there's not. They're just two, and they stay apart. Okay, so it's not Mariology in the strict sense. But I trust that Schaffer is talking about the same question that I'm asking. And so he says to go from atoms to molecules and from molecules to solid macroscopic objects and to tables and humans, you need substantive metaphysical principles. So that is my target, and I'll try to refute that. I try to show that Schaffer is wrong, although you'll see that I take a lot of things from Schaffer, but this is not okay. And I look at another example that is that I will not develop anymore in this talk, but it shows that this the question is very general, although I most of the time talk about atoms and molecules. This question may look more interesting to you if you consider other examples, and an example that is particularly fascinating and that I like a lot is and something that you think about in philosophy of mind is about phenomenal consciousness. And this is from Frank Jackson. So I wanted to tell you about it before putting the sentence on the slide. So Frank Jackson has a thought experiment with a person called Mary. This is from the 80s, 82, 86. And the aim of Frank Jackson's thought experiment is to argue against physicalism. So Jackson tries to show that physicalism is false, where physicalism is the thesis that in a metaphysical sense, everything is either physical or composed of physical parts, and either has either physical properties or properties that can be reduced to physical properties. So Jackson tries to show that there is at least something about human beings which is not reducible to physics and to other natural sciences, that is phenomenal consciousness. Why things appear to us in a certain way. For example, why we have phenomenal experience of colors. And so the thought experiment goes in that way. There is a hypothetical person that lives in a world without any colors. Maybe the light is just too weak, and you know, even in the evening, in the night, everything is just black and white. So you can imagine that it's coherent to imagine that there are circumstances where there's just not enough light to have colors. Otherwise, you can just live fine, and in particular, you can learn everything. So the thought experiment has it that this person knows everything in theory about color without having herself ever experienced color. And I think that it's conceivable that you could learn all. It's very difficult to learn everything about color, because you have to know both physics and physiology, because color is both, has to do with physics about wavelength and sort of thing about light, but it also has to do with our physiology. And for example, opponent colors like yellow and blue and red and green, why they are contrast, there are all sorts of optical effects. That is not explained by physics, but by the physiology of our organs, retina and optic nerve. And so to know everything about colors, you have to learn several sciences. But the idea is that it is possible to learn all that. You have all the science books and classes to learn all that without ever experiencing it yourself. And so then the thought experiment asks whether when Mary for the first time switches on the light, for the first time sees the blue sky or red seats, does she learn something? And Jackson says, obviously, yes. She would, wow, oh, I didn't know what it looks like. And so he says, physicalism is wrong, because if physicalism was correct, she would have known everything, because she knows all the science, and science tells you everything about the natural world, so she would have known everything. But she didn't know everything. She learned something when she first experienced colors herself, so physicalism is wrong. And so what Schaffer says about this, I turn briefly to Jackson's case of Mary, who is imagined to know every physical and neural detail of the world and to be able to draw all logical consequences, but to have never herself actually experienced red. Mary suffers from a twofold deprivation. So what does she lack before she sees the colors herself? Twofold, because one is she lacks concepts of colors. It's plausible that you couldn't possess or master a concept for colors without having experienced colors. But the controversial deprivation is that she has been deprived of metaphysical information insofar as she has not learned the relevant bridge principles. So bridge principles, we have talked about this a little bit this morning. To get from knowledge about the body and the physiology that makes us capable of seeing colors, to get from that to information about what it is like to experience them, you need a bridge principle. That is the theory of reduction. But Schaffer says these bridge principles, they are metaphysical, or at least in part metaphysical. And I say they are only scientific. Okay, so we'll see whether I can find arguments to show that this is wrong. And another philosopher who says that we need metaphysics to understand this sort of things is Kit Fine. Other great metaphysician and logician. A number of philosophers have recently become receptive to the idea that in addition to scientific or causal explanation, so all these people, they acknowledge that science is absolutely indispensable. You have first of all looked to science, but they say sometimes science is not enough. So in addition to scientific and causal explanation, there may be a distinctive kind of metaphysical explanation in which premises and conclusion, explanans and explanandum are connected not through some sort of causal mechanism, but through some constitutive form of determination or ontological ground. So when you want to explain the whole object, starting from premises that bear only on the parts, you need metaphysical principles, and the parts ground the whole. So this is a new concept, and I just accept that you can use this kind of concept to discuss this. So the question is whether ground is metaphysical or whether it can be understood 100% by science. So there's also, it's new, it's a fashion, it's fashionable to speak about grounding now. And I take it that it's a fruitful new concept. So let's see what we can make of it. But some people say, well, we should use, instead of grounding, building. Karen Bennett says building is better. Alistair Wilson says you should call it metaphysical causation. I think they are both not the best choice. Building is supposed to cover both what others call grounding and causation. So this is very important for the rest of the talk. I take grounding in the sense where the parts ground the whole. So the link between the parts and the whole, I accept to call it grounding. And I take it that this is very different from causation. And in a sense, everyone agrees that this is very different from causation, in the sense that causation is about links among things that happen, events that happen at separate space-time points. So if you have links between one object at one moment in time, it's not causation. It's other kinds of determination relations. But causation is always about what happens early and what happens later. So if I throw a brick at this screen, it will break. So that is causation, because the throwing of the brick is earlier than the breaking of the screen. And so that's a causal relation. But if I ask about what makes up the screen, why there's a screen and not only the particles or the atoms, that's not causation. Okay, well, I hope to understand this. So building is a concept that is supposed to be more general, and there's causal building and non-causal building, and metaphysical causation is a very bad choice of words, because it makes us confused, because metaphysical causation is not causation. So don't call it like that. Okay, so it's all about whether these are metaphysical relations and whether we need metaphysics to understand them, or whether, what I think correct, they are natural determination. They are non-causal determination relations between part and the whole, and we cannot understand them by science. And that's what it means to call them natural. They can be completely understood by science. Okay, so if the molecule is grounded, so now I just use this term, is grounded on the two atoms in a bound state. And the question is when you explain it in quantum mechanics, you learn this explanation. Is that metaphysics, or is it only scientific? So I first show you the bound state criterion for composite objects. And I tell you that I think that it's a scientific principle, scientific criterion, not metaphysical. Then I look at the analogy, what is common and what distinguishes this from causation. And then I look at three criteria that Barry Lower has recently put forward to distinguish between science and metaphysics. So I try to understand why people like Schaffer and Fine and Alistair Wilson and all these people think that we need metaphysics in addition to science. And I draw two consequences from my answer to these questions, which is that we don't need metaphysics. One is that there can be probabilistic grounding, and one is that natural laws are not among the grounds. So I start with a way to express the question I have asked by a metaphysician who is not doing metaphysics of science. So this is something I wanted also to, I have to tell you, which is not on the slides, that there are in contemporary metaphysics different ways to interpret metaphysical questions, and in particular the question of what makes it the case that sometimes the parts form wholes and sometimes parts don't form wholes. So you can tackle this in the framework of what many people and I call metaphysics of science, where you try to answer that sort of question within science, and you interpret the result as an answer to a metaphysical question. But it's all interpretation of science. But you can also ask these kinds of questions, and it's also, I think, an interesting and worthwhile enterprise. You can ask these questions in the framework of just common sense intuition. And Van Inwagen is into common sense intuition, and this is also very interesting. So in his words, this question, he calls it the special composition question. Let's just accept that he calls it like that, but you'll see it's exactly my question. It asks about the conditions a plurality or aggregate, array, group, collection, or multiplicity of objects must satisfy if they are to compose or add up to something. So that's the question. Why are there composite objects, not only simple objects? So I will not talk about Van Inwagen anymore, but just to say you one word about what he's doing, because that is allows me to illustrate that other way of thinking about metaphysical question, which is all justified by common sense. The criterion of what is true in that sort of metaphysics is all common sense intuition. So he asks, in looking for the criteria that make some things constitute wholes and other things not constitute wholes, he says, well, let's see whether contact is enough. So he says, if we shake hands, we are in physical contact. Is that enough for us to constitute a whole? So, well, it's an interesting question. It might be that it's enough that this and the table, they are in contact. Maybe there's an object that is constituted, that has as its parts the table and the goblet. And in the case of two people shaking their hands, common sense intuition says, no, there's not. They keep being two. There's not one chimerical double person. No, they're just two persons in touch. So physical contact is not enough to make up for composite objects. And then he asked about Siamese twins. What if you have a sort of Frankenstein and you would sew some two people together, or maybe two animals, and make them stick together forever and live together? Would that mean that they are one? Intuition would say, no, they're still these poor creatures. They stick together, but they're still two. Okay, so there are common sense intuitions, and Van Inwagen tries to find his answer in that framework. But I asked for physics, and physics says for physical objects, there's a simple answer. And Mackenzie and Müller call it the bound state criterion, and it says physical objects form a composite objects if and only if these physical objects interact and are in a common bound state. So that is chemistry. You learn that what molecules, what makes a molecule is atoms that are in a common bound state. So they say that's exactly the answer to the Van Inwagen question from a scientific point of view. And I think it's almost correct what they say. I think this is a sufficient condition, and I'm not I criticize them just for saying that it's also a necessary condition, if and only if says it's necessary and sufficient, and I think it's not necessary, and I have two arguments for that. So I go back a second. So if the atoms are in a common bound state, that explains the stability, because the quantum mechanical explanation says that if the atoms are in a state where the orbits of the electrons overlap, they would form a common orbital state. All the electrons will be in a common state, and that state has lower energy compared to the energy of the electron orbits if they are not in a common state. So the stability is explained by the fact that the energy is lower. So as long as you will not separate them by putting energy into the system, heating it, for example, they will stick together because that's the lowest energy state. So that makes for the stability of the molecule, and the fact that it's stable is an important part of the fact that it's an object. It's not two, but it's one object because it is stable. So it yields the intuitively correct answer to the question. If you compare two atoms that are very far apart, or that are just in two rooms of this building, they don't form one object. And if they are close enough together that they have overlap and are in this bound state, they will form a composite whole. So I think it gives the correct sufficient condition. And it's not a necessary condition for, at least I found two reasons. One is entangled particles in quantum mechanics, where you have these experiments that were first conceived. It's called EPR because Einstein with collaborators had conceived this as a thought experiment in the 1930s. And it was then realized as a real experiment in the 1980s, I think 80s or 90s. And there you have particles that are related in a very special and very surprising way after having interacted, and they can be far apart from each other and still be related so closely that there seems to be instantaneous interaction, which cannot be because the physics of relativity forbids transmission that is faster than the speed of light. So simultaneous at a distance is not possible. So one solution to the problem is to say, with Schaffer and Calosi and Tarozzi, they are not two particles. It's just one particle that is spread out in space. And so that's all hard. It's not really, it doesn't make the puzzle go away, but it's one way to make one step towards explaining how it can be that they are related, although they are far apart. Well, for me, this is just interesting because you have one object that is constituted of these entangled particles, and they are not in a common bound state in the chemical sense, but they will still be one object. So that would show that the Mackenzie and Müller criterion is not necessary. There can be objects that don't satisfy it. Okay, and the other maybe even more spectacular and more simple counterexample to Mackenzie is that some philosophers of biology, Kistler and Hull, they have put forward the idea that biological species are not sets of individuals, but they are individuals. So the organisms, if you think of the human species, usually we think that all humans form a set. So we are members of a set. And so there are lots and lots of humans, because also you have all the humans in the past and the humans in the future. Well, they are a big, very large set. And these people say, if you want to understand evolution, and the best way to conceive of biological species is to take them to be individuals, not sets. So we would not be members of the human species, we would be part of the human species. So there is part and whole. We are parts among many other parts, and the human species is the whole, but we are not in a compound state. So this would be another counterexample. So my topic is whether this bound state criterion, whether this is metaphysical or whether it's just scientific. And McKinsey and Müller also say this is relevant to the special composition question, although van Inwagen doesn't talk about science, but they say, well, this is exactly, this is a question we can try to answer within science. But it's a question discussed in metaphysics. And so is the answer metaphysical or not? It's based on a scientific explanation. I have already said a word. So in one paper on this topic, I read quantum mechanics explains why the overlap of the electronic orbitals of the atoms in a chemically bound state leads to a minimum of the overall energy. That's what I have already said. And so, well, using this to answer the question, does it provide metaphysical in the sense of non-scientific explanations? So now I look at the analogy between grounding and causation, because I think that will illuminate our way of thinking about this and will show what is going on and why we disagree with Schaffer and Fine. So metaphysics comes into the picture when it comes to interpret science. So one thing is to understand what physicists tell us about composite objects and bound states. So I learned this in chemistry. I don't know physics. I don't know and don't need any metaphysics. But if I want to understand whether that tells me something about reality, I'm in metaphysics. And to tell you a little more about this, I compare causation and grounding. So I have these two relations between cause and effect and between parts and whole. And in one case, the relation is causation, and in one case, it is grounding. So this is already metaphysics, because even if all the information about what causes what, we get it from science, we don't need metaphysicians to tell us whether colibacteria cause cholera. Well, we need medicine and physiology and epidemiology. No metaphysics needed. And when we want to know what causes you to understand what I say, we need physics because there are sound waves, and we need physiology because there's my brain and my vocal cords and your ears and your brain. And so we need a lot of science, but we don't need metaphysics, I think. But if we want to know what it is that one thing causes another, that is a metaphysical question, but we can ask it and answer it just by interpreting science. So that is my idea about how metaphysics can come in addition to science. It is, if we want to understand reality, both causation and the structure of things, like how they are made up from their parts, we can interpret science. So we have, in one sense, it's the content is all scientific, but the interpretation of that content, which is that in which way it tells us about what is there really out there, not only in the science textbooks, but in reality, that is that can be expressed in metaphysical terms. So if you have causal explanations, the explanation is all scientific, but the metaphysics comes in when I say, well, this is explanation. It's not just an explanation. Explanations can be interesting, can be long or short, can be relevant or redundant. and all sorts of pragmatic criteria, which they are tuned to the audience or not. Some explanations are redundant for some audiences. Some are too quick for some audiences. So that is all about explanation. But there's one thing that is especially interesting about explanations is that they are sometimes true and sometimes false. And so the difference between the true and the wrong, that is a metaphysical explanation, I think, because the true explanations, they have a truth maker. They correspond to something in reality. Well, that's a metaphysical thesis. So causation is something in reality that makes causal explanations true. And so my idea is to make this parallel and to say the relation between the parts and the whole, I call it natural grounding to go with everyone else. And the content of, to know what grounds what, we have to ask physics and chemistry. But when we interpret that and try to say what it means for what it tells us about reality, we say some of these grounding explanations are true and some are false. And when they are true, they have a truth maker. There's something in reality that makes it the case that they are true. And that is a grounding relation. And the fact that there's a grounding, the thesis that there's a grounding relation is a metaphysical thesis. So postulating truth makers is a metaphysical thesis. But the nature of both causal and grounding relations, so what causes what and what grounds what, is all known by science. So we don't need metaphysical principles, as Schaffer says, or metaphysical laws. Schaffer also says they're metaphysical. They're laws of metaphysics. I don't think so. So the mass of the complex object. So now this is a little bit more detailed. The mass of the complex object. So before I asked why there are complex objects, now I ask about one of their properties. Why does the composite object the mass that it has? Well, which is the mass of the complex object? Given you have the masses of the parts, you have to ask physics. You can't know like that by just thinking. And physicists know because they weigh things. They just check. You have two. You put it on the scale. Then you put it together, make a whole, like you make it merge or make a molecule, and then you put it on the weight, on the scale, and you check what's the mass of the composite, given that the mass of the components. And physics has changed its mind about this. So it's all experience. In Newtonian physics, it was thought that if you put together two atoms or many atoms, you make a crystal, a solid microscopic objects. So what's the mass of the whole? Well, it was thought it's just the sum of the masses of the parts. And contemporary physics thinks it's a little bit, it's a function that is a little different from addition. It's not exactly the sum of the parts, because the mass of the whole also depends on the energy of the bonds. And so there's a little difference between the arithmetic sum of the masses of the parts and the mass of the whole. Well, it's all scientific. You have to find out by making measurements. It's not something you can learn either in mathematics or in metaphysics. You have to do experiments. Okay, so now I look a little bit at this. What's the difference and what's shared by causation and grounding? And I take all from Schaffer. That is looks a little technical, but I think it's worth, and you'll see it. It is not so. It's not necessary to go into difficult details. I hesitated a little bit whether that was too technical. Well, you tell me afterwards. So they are both. This is also a justification for why I think it's okay. It's a good idea to use this concept of grounding, because it has these formal properties that makes it an object of rational study. And so they are what they call strict partial orders, which means they are both irreflexive. Nothing can cause itself and nothing can ground itself. asymmetric if throwing the brick breaks the glass. It's not at the same time the other way around. And it's also with grounding, the parts ground the whole, not the other way around. And transitive means if like you make fall a series of dominoes, if a first event causes a second event, and the second event causes the third event, or in a billiard game, you kick one ball, and the ball you have kicked then kicks another ball. This is as a consequence, what you have done to the first ball has a consequence on the second, in the sense that when the first causes the second and the second causes the third, transitivity means that this implies that the first also causes the third. And intuitively, if the second ball kicks the third ball and that falls into the pocket, you have put it into the pocket. And so intuitively, causality is transitive. And grounding is also transitive if you have parts making up a whole, and that whole makes up a bigger whole with other parts. It's also transitive. The smallest will also ground the biggest. So they share these formal properties, and they have other interesting aspects in common. One that we have also already mentioned is that both back explanations, causal explanations, are allow you to explain things. Why is this window shattered? Because someone threw a brick. Okay, now I understand. This is a causal explanation. So knowing causal relations allows you to explain things. And the same for grounding. If you want to know why the whole weighs a little less than the sum of the parts, you can explain this by learning about this very special grounding relation. And it also allows you to justify counterfactuals. That's also very interesting and common to both, because I don't want to shatter any screens or windows, so I will certainly not throw anything. But to protect things, I have to know that if I do certain things to them, they will shatter. So I put a big tag, fragile, on fragile things, so not to shatter them. But why would I put fragile if not because there's the possible situation in which this thing falls and then it will be broken. So if I want to know about possible situations, I need counterfactuals, and I say, this will never fall and this screen will never break because I take care of it. But if it fell, or if I threw something at it, then it would break. So how can I know? How can I know that? It will never break. How can I go to a possible world? How can I observe what happens in possible worlds? I cannot observe. It's just possible. I can observe only what's actual. How can it be? Well, causation allows you to do it. And because you learn everything about causation from science, science allows you to do it. So you can learn that from what you know about causation in the actual world to what happens in possible situations. And so it justifies counterfactuals. And it's the same for causation and for grounding. And so this is the technical part. It can be expressed by structural equations. So here is a structural equation model for causation. That is also something I take from, there are many presentations of this, which has proven very fruitful in the theory of causation. And so this has not been invented by philosophers, but by computer scientists who are busy understanding how scientists go about discovering causal relations, especially scientists who try to understand complex situations like epidemiology, what substances in the air, in the water, or in our food increase the probability of this or that disease or allergies or this kind of thing. You know, this is very complex. You have many variables, many things to take into account. And how do you go about finding out what causes what in that kind of circumstances. So to improve the research for causes, there are these formal models elaborated by logicians, computer scientists, and that philosophers just observe what these people have done and try to understand what's going on. So such a causal model has three or four ingredients. And this is the simplest possible causal model that I can think of. Throwing causes shattering. So it's the same example as I already gave before. Everybody uses that because it's so intuitive. Throwing and breaking, everything, and everyone understands what's going on, what causes what. So we have two sorts of variables. Then this is just the skeleton, and we can make a model of that sort for situations which hundreds of variables. We will not do that. We try just to understand what's going on in principle. So we need two sorts of variables. They are called endogenous and exogenous. And the endogenous variables, shatter is endogenous, and we have only here we have only two variables. So there's a set of endogenous variables which has only one element, because this is the simplest model I could make. So the endogenous variables, they are such that their value is determined by other variables in the model. So R1 is the function that attributes values to these variables. So here it's just 1 and 0. 1 represents the fact that, yes, the window shatters. 0 represents the fact that it doesn't shatter. And so whether or not it shatters, whether its value is 0 or 1, is determined by something else in the model, which is the other variable, which is exogenous. Whether it shatters is determined by the fact that, by the value of the variable throw, which can be yes, I throw, or no, I don't throw, 0 or 1. And the value of this variable throw is not determined within the model. It's outside of the model that determines whether or not the throw happens. So the most important part is the structural equation, which is this one. So I don't write it as an equation, and you can write it as an equation, but then you have to add immediately a remark to say it's not an equation like in mathematics, because it's asymmetrical. So it's better to represent it by an arrow. And here also there's the same arrow. The value of this is determined by the value of this. And so there's an asymmetrical relation. It's not really an equation. And the last part is the assignment, which is to specify the situation. And this here, it says, yes, the throw happens. And then if you have a model, you can use it to predict what will happen. So this is here, it's very trivial. But if you know that there's a throw and you have this model, you know that the window will shatter, because shattering is determined in a perfectly deterministic way by throwing. So you can read off the value of the endogenous variables once you have the model and the value of the exogenous variables. Okay, so that's all about the structural equation model. And now what I tell you about what is Schaffer's thesis, and I agree with him, is that we can make use the same formalism to represent grounding. And I think that he does not use that example, but I like this example because it shows that you need science to make that model. And so now I switch to, before I use the example of molecule and atoms, and now I go one level deeper or lower, and I look at the parts of the nucleus, because in an atom you have a nucleus and the electrons, and in the nucleus you have parts which are protons and neutrons. And so what is the mass of the helium nucleus? So it has 4 parts. 2 of them are protons, so it's the meaning of the 4 and the 2. So what's the mass of the whole? And the model says the mass of the whole is determined by the masses of the parts. And it's not causal because there is no difference in space of time. It's one object and its parts at the same moment. So it's I accept to call that the grounding relation. At any rate, it's a non-causal determination relation. And the structural equation here that gives you the answer to the question how the mass of the whole is determined by the masses of the parts. It's a scientific equation that physicists have found out by taking measurements. So it's a posteriori. It's not mathematics or metaphysics. And what's especially interesting, and then here are just the weights of the proton and the neutron. This is the weight of the neutron. These are just units because they are so small that you can't. It's not useful to weigh them in grams and kilograms. So they have these atomic mass units. And so what's interesting is that the sum of the whole, it's the addition of the protons mass, the addition of the neutrons mass, and then you have this term minus delta m, which is the mass defect. There's something going away. You put the parts together and something disappears because you gain energy. And in fact, it will be sent off by radiation. Well, and so all this is just, the only point I want to make is that this is found out by science. So it's not, you don't learn that by from metaphysicians. Okay, so the structural equations express functional dependence between variables. So, and now comes a very important part for the rest. That dependence that figures in these structural models, in both the causal case and in the grounding case, it is natural. And what I mean by natural is that it's all discovered by science. But you can also make models for fields that are outside natural science, and you can have structural relations that are determined by logic. So I give you some examples. But in the case of natural determination, these structural equations express empirical laws that are discovered by experience, causal laws or non-causal laws. And to get back to metaphysics and science, so the explanation is first of all scientific, but then metaphysics comes in later to just interpret the scientific explanation and to say there's something that makes it true. And what's true is either causal laws or non-causal composition laws, as I call them in case of natural grounding. So why would people like Schaffer and Fine and Bennett and Wilson, why would all these people think that natural grounding, so the relation between parts and whole, is metaphysics and needs metaphysics and not only science? So Schaffer says the epistemic gaps between the existence of the parts and the existence of the whole can only bridge by metaphysical principles. We've seen that before. But why think that the explanation requires metaphysical rather than scientific principles? So what I criticize is that they would agree with me about causation. They would say, okay, yeah, if it's called causality, bacteria, viruses cause diseases. Okay, that is laws of nature. What you discover there is cause of nature. So if you make a model, you have these structural equations. In the case of causation, they express laws of nature. But in the case of grounding, no, there you have metaphysics. They said, no, it's the same. It's also laws of nature. There's just non-causal laws of nature. So why would they think that you need laws of metaphysics? The thing about the mass defect, this is not a mass. This is not a law of metaphysics. And Schaffer would agree. Next time I meet him, I'll ask him. I'm sure he would agree. So I think what's going on is this. And it's a simple logical mistake, but I'm a little I have scruples to accuse Schaffer of logical mistakes. So it would be better if he was here. So he would show me that I make lots of logical mistakes. But well, he's not here. I try to show you that there's a little mistake in argumentation. So I think behind this thesis that you need metaphysics is the idea that some paradigmatic cases of grounding are justified a priori, independently of science, independently of empirical facts, independently of laws of nature. So here are these other forms of grounding that have nothing to do with natural science. So there is semantic grounding, and I accept that these are also called grounding. So what grounds the truth of a conjunction? It's the conjuncts, together with a semantic rule about how conjunction functions. The truth table tells you what's the conjunction. And so the ground of the truth value of the conjunction, of the semantic whole, are the semantic parts. And Mariology, I mentioned it before. It's an axiomatic theory, like logic. It's a kind of sort of logical theory. What makes up a Mariological sum, which is written like with the plus sum symbol? Well, it's the two terms. And set theory is another theory where you can use the concept of grounding. And all these people, they use all these examples to say they all share these interesting structural features. So if you have Socrates, you also have a set which contains Socrates as a member. That's called a singleton set. And why is this? Because this is follows from the axioms of set theory. It's like Mariology. You have just any two objects. The axioms tell you you have a set that contains these any two objects as members. So this is just follows from the axioms. And you can say Socrates grounds. What is the explanation for why exists this set? It exists because Socrates exists. And given the axioms of set theory, Socrates grounds the set. And so there are all these forms of grounding that are not scientific, has nothing to do with empirical science. And so I accuse Schaffer and others of making the mistake to say, because these are not scientific, no form of grounding is scientific. And that's, of course, past pro toto fallacy. And what I think is, and what I have already tried to show, is that there are cases of grounding that are scientific. And this is compatible with the case that there are cases of grounding that are not scientific. So, well, it's obvious that that would be a mistake to think, because there are some, all must be like that, all must be non-scientific. Okay, so now let's look a little bit closer at the reasons behind the thesis of my opponents. And I think you can make progress in understanding what's going on by looking at 3 criteria that Barry Lower has proposed for distinguishing science and metaphysics, or scientific and metaphysical explanations. So they are in this paper from 2012. And so the first criterion says metaphysical explanation need not involve laws. whereby he means laws of nature, whereas scientific explanation does. So Barry-Lower accepts with everyone else that scientific explanation uses laws of nature, but metaphysical explanation not always. And it's correct because you can consider the explanations in the list as metaphysical. Well, they are really logical. I give you an example of something that is really metaphysical, and which is has nothing to do with laws of nature. Okay, but what this criterion suggests is that grounding is metaphysical because grounding doesn't require laws. So grounding never requires laws. But that is a presupposition which is incorrect, as I have already said. It's not true that grounding never requires laws. Here is an example of a determination relation, which is maybe really metaphysical in the sense that it's not scientific, but it's also not logical. And an example given by Schaffer and discussed by many papers on that topic. If you have shades of colors, so maroon is one shade of red, and so when you want to know why the shirt is red or why these seats are red, you can say that the fact they are red is grounded on the fact they have a specific shade of red. Okay. Why is it red? Because it's carmine or maroon. And that seems to be okay as an explanation. And it's also, I think it's also okay to call it grounding, that the abstract color is of an object is grounded on the fact that it has a specific shade of that color. Okay. And so this is not, it does not involve laws. And so it's supposed to show that grounding never involves laws. So grounding is always metaphysical. And that's not wrong. That's not correct, because sometimes grounding involves laws. And then it's not metaphysical, but scientific. So I switched to third criterion because I think I take them in the order of importance. I think the second has the most importance. The third criterion says one difference between metaphysical and scientific explanation is that the latter, but not the former, may be probabilistic. So in science, you have probabilistic explanations, and all the examples I have talked about in epidemiology and climate science, all these, economics, psychology, all sciences that have to do with complex situations, they have only probabilistic laws. In medicine, you have this and that remedy, and it's always about how much of the patients will be cured. It's never 100%, and it may be 0, but it's never 100%. Okay, so in science, many explanations are probabilistic, and the idea is that in metaphysics, there are no probabilists. It makes no sense to have probability in metaphysics. Maybe metaphysics makes sense, and I just try to give you an example. It makes sense to say it's red because it's maroon, but it wouldn't. It would be a mistake to try to use probability in that circumstances. So that okay, so that seems to be a big difference between metaphysics and science. And so everyone, and also Lower, assumes that as all metaphysical relations, grounding is deterministic, and some scientific determination is sometimes probabilistic. But it doesn't follow that grounding is always metaphysical, because you can have metaphysical grounding relations which are all deterministic, and you can have, in addition, scientific grounding relations which are or are not probabilistic. So if natural grounding, as I think natural grounding corresponds to here it what I've just said is a little is not precise, because if I have time, I will eventually question this, but we might just as well accept that natural grounding, as all grounding, is always deterministic. So we might accept that all grounding is deterministic, even natural grounding, it might still be scientific, because that's our question. So even if it's true that all metaphysical explanations are deterministic, it doesn't follow that if you have a deterministic explanation, it's necessarily metaphysical. It looks more confused than it is, but I try not to say it once again. So scientific explanation can be probabilistic, and the question is, what is the case for grounding? And we may well have that grounding is always deterministic, and still in some cases it's natural, and in the cases concerning parts and wholes it's natural, even if it's deterministic. Okay, so this doesn't show that my grounding relations between parts and wholes cannot be scientific. So that's the point. And the most important is the second, and that has to do with the distinction between causation and non-causal dependence. In a metaphysical explanation, the idea is that metaphysical is not causal, and of course that's correct. So in a metaphysical explanation, the relation between the premises and the conclusion is co-temporal. So we always explain something that by other things that concern the same moment, in case we explain something that is in time. Whereas for lower, and I think that's really the deep reason behind all this disagreement, that scientific explanations are always causal. And I think that's really the point. Typically, scientific explanations typically show why something later happens, given you have something earlier. So it's a causal explanation. Typically shows why the event occurred later in terms of what happened earlier, in terms of prior events and laws. So this presupposes that there's a dichotomy that divides explanations on one hand in scientific, causal, and diachronic. So science is always interested in causal explanations that have to do with things that are distant in time, whereas metaphysics has to do with things that are not distant in time. So it looks plausible, because if you accept that all scientific explanations are causal and have to do with things separate in time, then grounding must be metaphysical, because it's not causal. But it's not true that all scientific explanations are causal. And it has been criticized, for example, by Salmon in the 80s. And recently, many philosophers have thought about non-causal explanations in science, especially in biology. This is my colleague Hünemann. And they have thought about cases of non-causal explanations that are mathematical. So I don't try to give you a serious example. There are some nice examples, but just one example that is in Lange's book about non-causal explanation is I try to share strawberries among my kids, and I have 13 strawberries and 3 kids, and I cannot make a fair share. And the explanation is that it's a mathematical fact that there's no way to divide strawberries, divide things divide 13 things by 3. It's not divisible by 3. That's just mathematics. So the fact why I have to cut them. So I can't do it if I don't want to cut them. So you explain this very simply just by the mathematical fact about the numbers 3 and 13. So this shows that not all, and you have serious and interesting explanations like that in biology about cycles of plants, plants that have 12-year cycles, and they're super interesting things. And you can explain them with mathematics. It has to be 12 because 13 would not be divisible on things like that. Okay, so it's interesting, but from that you could just get the impression that what is correct is it's not true that all scientific explanation is causal, but it's true that all but it's what is the case is that is either causal or mathematical. Instead of saying that all scientific explanation is causal, now they say if it's not mathematical, then it's still causal. So if it's a posteriori, if it uses laws of nature, then it's causal. That's not true either. And so these they're not simple, but they are relatively simple explanations of scientific explanations that are not mathematical and are not causal, and which are not about causation, which are not about grounding, that just physics that you learn at high school. So these two examples, they're simple equations about pendulum, which says that the period, which is the time a pendulum takes to go back and forth a whole cycle, that time only depends on the length. So if you have a pendulum with 1 meter length, it makes no difference at all whether there's a very big, very heavy object that swings back and forth, or whether you have a feather or a very tiny grain of sand. You must do it in the vacuum, of course. It will still swing always at the same period. It only depends on the length. And how it depends on the length, you have just this equation. You find it out by experience. G is a constant, and otherwise there's only P. And about gases, you have another example, which is that the temperature depends on the pressure and the volume. This was found out by experience by making measurements on gases. So both of these, they are not causal because they are, you can use them to make non-causal explanations because you can use them to explain one property of an object in terms of other properties the same object has at the same time. So that is non-causal explanations. It's not about what happens early and later. So there are also non-causal and non-mathematical explanations. And I try to see what's going on, what's the mistake in the reasoning. In a metaphysical explanation, I think this is still lower. The explanandum and explanans must be cotemporal. Okay, let's accept that in metaphysics you don't provide causal explanations. If you talk about part and whole, well, that's first of all scientific. But if you talk about red and maroon, that is about one object at one time. It's not causal, okay? In science, typically you are into causality. So I just observe that this may be true, but there are these atypical explanations where you have explanations that are non-causal. And my cases of part and whole, they are these sorts of explanations. They are still scientific, although they are not causal. Okay, so all that I take it to makes it plausible that grounding is nomological in the sense of scientific depending on laws of nature. So nomological means it's structured by laws of nature in the same sense in which causal relations are structured by causal laws. So in case of ground, there are laws of nature that mediate exactly as in the case of causation. And now there are two controversial consequences, which are that contrary to what I have considered before, because it was in lower, natural grounding is not necessarily deterministic, I think, and it's not true as Nina Emery has said and argued, that among the grounds of composite objects, they're not only the parts, but they're also laws of nature. So I try to argue on the basis of what I've said before, that the grounds are just the parts. Laws are not the sort of thing that should be considered as grounds, given what grounding means. But I might as well stop here. I haven't observed what time it is. I don't want to take too much time. It's already 7:30. I think that better to stop. It's already longer than I expected.
Thank you. Well, I have a point to raise, but given the issue of time, yeah, no problem. I prefer to leave the stage to Samuele Fasol for his comments. Yes.
Right. Thanks. Thank you very much for the talk. It was very clear, and I also really enjoyed the paper that was dense but very insightful. I have formulated 3 questions. And so the first one is about the bound state criterion. And my concern is about assuming the notion of object. Let me make some considerations on this point. I believe that bound state explain why a set of atoms or molecules stick together and not why they compose an object. Of course, you can identify the two. You can say that an object is the fact that some atoms stick together, but this is a claim that goes beyond science. So maybe you need some more metaphysical tools to claim that. I was thinking about the example of, I don't know, 3 H2O molecules. Why do they compose an object? You need an account of what an object is. And this is related to another point, which is the same problem, but in different words. You say that the bound state criterion is a sufficient condition to compose an object. And to find a counterexample to that, one should find a case of 2 elements in a bound state that do not compose an object. But this means that we need a definition of object which is independent of bound state. And so I was wondering whether you have these definitions and whether you can ignore any metaphysical tools that you wanted to eliminate in providing these definitions. And by the way, I think that this is just a comment to my question. Schlick's account that you mentioned on the paper, I think is not trivial, because he's exactly pointing that we need some conventional definitions before our account of wholes and parts. And maybe this reintroduces also some a priori elements in science. You made the example of mass. Of course, we can measure mass, but first we need to define it. For example, as the coefficient of a structural equation of Newton's second law. But maybe this is an a priori definition. So this question is, what is an object and how can you define an object with only a posteriori elements? My second question, so you already said that actually grounding can be both metaphysical or scientific in different senses, in different ways. I just wanted you to elaborate a little bit more on this distinction, because it is not very clear to me. I think that the relationship between molecules and atoms, for example, is a specific case, while the relationship between wholes and parts is a general case. And when in metaphysics we study, I don't know, grounding or compositional definitions, we are talking about the general issue. So are you reducing the general issue to the scientific one? Or if not, you're just finding a very little area of relationships between wholes and parts in which the bound state criterion is sufficient, but it is just on the specific case of molecules and atoms. Last question, third question, very briefly. In the paper, you mentioned that grounding laws mediate, but they don't ground. And I was wondering whether laws are then fundamental or not. You think they can be viewed as prior to object, to the relata of these structural equations, or maybe first we have objects and then we have the relationships, the laws. And that's it.
Okay, thank you very much. I'm not absolutely sure whether I understood the last, but I may, yeah, I'll tell you. So I think. Oh, okay. I use this one.
Yes.
Okay. I suppose that I said unfortunately Schaffer is not here, but fortunately you are here, because I think that is probably something like that he would have said, and which is the right thing to say, that indeed to ask these questions we need concepts, and the concepts in which these questions are put are metaphysical, and the concept of an object is a metaphysical object. You're absolutely right. And I think all I can say is that, but I don't even say see how whether it's not also the answer to the second question, that indeed maybe all I say is not enough, or you can challenge me to say I should say more, because it only answers part of the question and not the general question, but only a very particular case. And I agree, and I admitted that this is an account that works only for molecules or maybe solid state objects in physics, but it doesn't work for biology. And I said it myself. So in a way, it's not really the whole truth about this matter, because there are, and I even in physics, I gave this example of the entangled particles where there's something else than to be a bound state. So it's just the idea that this is a very, very important case and quite fundamental, because they are very simple objects. And in that case, the explanation is all scientific. So it makes it plausible that there's also an explanation of the same sort in other cases, like in biology, but it doesn't, of course, it's not really the same to show it for one case and to suggest that probably works also for other cases. would take much more time, much more effort, and I don't know how to go about showing it in the general case. That's why I didn't. I mean, I don't know how I could possibly argue for this in the general case. But it's still an argument. But well, it's weaker than we might have hoped. And I also, I think you were right also about the fact that I only said stability is part of what makes up for an object, but also you have independence, and you have the fact that it's separate. It has boundaries, so there are these metaphysical criteria for what is an object, and I didn't bring them in, neither in the talk nor in the paper. So maybe that is certainly a weak point, because my good opponent, like you, and I'm sure you can accuse me of not playing a fair game, because I use a metaphysical concept without putting all my cards on the table and saying, here we cannot even ask a question without metaphysical tools. And I should do it. I think it would make my case stronger. So you're right about that. And the topic that I did not talk about is Nina Emery. She has this paper about laws and grounding, and says what grounds things are laws. And in particular, molecules, they are grounded by laws. And so I suppose she also would hope to use this as one step towards the thesis that everything is grounded on laws. And so against that, I use the analogy with causation, and she says herself that in case of causation, there are laws involved. If you want to know why, if I throw something, it will break the window, you need physical laws, inertia, and conservation of momentum, and that sort of things. But these laws, they are not the causes. That's a conceptual point. The cause is the fact that I throw. And the laws mediate between the cause and the effect. And so I just say it's the same with grounding. You have, if you want to know the ground of the mass of the whole object or of the whole object, the grounds are of the same sort. They will be other objects or properties of other objects, namely the parts. And then you have in between, you have these laws that mediate and that are discovered by science, and that I have shown you in the slides. And so the laws play a role, but it's not the same. It's not the role of the ground. It's the role of mediating between the ground and the grounded. But so what you said is whether the laws are fundamental. And so the laws are structuring relations. They are not in time, I think. Causes and effects are necessarily in time. They are things that happen in space and time. But the laws are not something that begins to exist at some point. They are not in time. Well, that is a tough metaphysical topic. And this morning I said something about laws of nature. There are, but no one would say that laws are, oh, no, you should never say that. But in the most important theories about laws take them to not to be in time. But once I said it, I know that there are also people who try to consider the possibility that laws themselves might change. And that might also be a serious physical possibility that over the course of the universe, not only what happens changes, but maybe even the laws that structure what happens change. But so put that to one side. If you consider just things that happen here and now, no one would say that in between yesterday and tomorrow the laws change. So they are constraining what happens and what causes what and what grounds what, without themselves being in space and time. So is that an answer?
Yeah, great. Thanks.
One point connected to the issue of laws, which is, as far as I could tell, in the paper and in your talk, you mentioned the role of laws in terms of mediation and so on. But of course, we all know there are different accounts of what a law is, and that debate is strongly metaphysical in nature. The character of laws, at least according to some of these options. So my point is, in your view, are there accounts of laws that match, that adapt better than others to your idea about natural grounding?
Oh. Okay, thank you. I think that these are they don't raise any particular difficulty that makes it more difficult to understand grounding laws than it is to understand any other laws. I think the difficulty is to understand what laws are in general, but grounding laws are not any more difficult than causal laws. Like this law about how the mass of the nucleus depends on the mass of the protons and neutrons. It is hard to explain what that is if you don't want to accept the empiricist thesis. We talked about this in the morning. The empiricist thesis which is that all there is to laws are just regularities. So that would be easy, or it's something that philosophers who are suspicious of metaphysics and many philosophers are suspicious of metaphysics in philosophy of science. So they like the idea that to do away with mysterious metaphysical postulates and say laws are just regularities. So what I mentioned this morning, the best systems analysis, it says more or less it comes to the idea that laws are just regularities. So it would be just every scientist who has measured the masses of the components and the mass of the whole has found that. So we write down a regularity. And then if we are good scientists, we will discover, or we construct a theory where we can derive that from axioms, and that's even better. But it's still all only consequences of observed regularities. But as I said this morning, this is not satisfactory, because the laws are more than just regularities. And one reason is that they apply also to possibilities and to the future. And that's not such a good argument. Better to say they also constrain possibilities, because the future, you can say, they are still part of regularities that we don't know yet. better to say they constrain possibilities. That is really something that is different from regularities.
But do you think that it would be possible to have a kind of natural grounding notion, even with an account of laws in terms of best system analysis?
No, I think the best systems analysis is not satisfactory in any case. It's not satisfactory for the ideal gas law, and it's not satisfactory for the composition of masses, and it's not satisfactory because this morning I mentioned one reason I just mentioned now is that laws also cover possibilities. So there's this intuition, which I think is correct, and I'm sure also scientists share, that it's not by chance. It's not just an accident that we find these regularities. There are accidental regularities. Sometimes just happen and there's no reason. And why the mass is composed in a very specific way, this is not just an accidental regularity. So in a sense, masses must compose like that. And the temperature of the gas must depend on the pressure and the volume in this way. So we have this modal strength, and it's the same thing to say they must behave like that, and to say it also constrains possibilities. So if we think about what we might do, we know what we talk about because we have laws, and laws cover possibilities that are not among the real world, in the real world. So all that is something that the best systems analysis cannot talk about. In the best systems analysis, there's nothing about possibilities and about modal strength. And so the reason
for them, it's the virtue.
Okay, because you might just reject the you might say there is it's an illusion to you, or why would it be a virtue?
It's because in some sense in the Lewis's analysis you want to get rid of modal notions.
Okay. Oh, okay, yeah, that's true.
So suppose that evolution had made us incapable of thinking about possibilities.
Yeah.
Suppose we human beings are just able to take into account actual events. Maybe in that case, a kind of best system analysis would be fine, and then you might have a natural grounding approach, which is based on account of law, which contains no modal strength at all. But this, this is just a bit speculative.
It's very interesting, but I think it's incompatible with science. I think it is.
No, I agree. On the point, I completely agree.
Essential to science, but also to most human activities or engineering. It's all about possibilities, because if you construct bridges at the moment, there are many bridges that break down even without earthquakes. So if you construct a new bridge, you are very worried about all sorts of possibilities, and you will calculate all sorts of possibilities. And but it's interesting to think about this possibility that we are dealing possibilities. That's why we are very good at making bridges and buildings that don't fall down and so on. But what about animals? Maybe animals do not reason about possibilities. So if they could do if they could discover laws, well. But I think there's also this other problem that I mentioned this morning, and that I think has moved. There are papers by hardcore empiricist philosophers, like as they say, humans, because David Lewis calls this humanism. Whether or not it has something to do with the real human is another question, but they call it humanism. This thesis that there is no modality or there is no necessary connections in nature. So even these people admit that there's this circularity problem, that laws are can be used to explain things. And if we want to know why I fell ill, or why there's a rainbow, or why we can look through the window, we use laws. So the laws help us explain things, and everyone agrees with that. And these hardcore empiricists or Lewisians or Humeans, they admit that there's a problem if you want to say that laws explain, because in the Lewis best systems analysis, the laws are explained by the facts. They are just
the summary of facts.
Summaries of facts. And so how could something that follows from a summary of facts explain those facts, of which is a summary? No, the summary is explained by the facts. It cannot at the same time explain them. And that has been discussed. I think that is really tough. And I think they have rediscovered exactly the same issues that are in the Treatsky paper. And so I think the best systems analysis just is not enough to make us understand science and solve this problem.
Any questions or remarks from the audience? So maybe we can stop here. Thank again, Max.
Thank you for being here. Thanks for the questions.
Great.